Hey, Physics 30. So here's lesson 2. So it's going to be similar to the last one, but it just gets kind of like a lot more convoluted because now what we're doing is conservation of momentum in 2 dimensions, right? So last time it was in 1 dimension, like a straight line, right? This ball hitting this ball, right? Now what we're going to be doing is having like, this ball hits this ball and then they go off in different directions, right? That one goes that way, maybe that one goes that way. So that type of a thing. So 2 dimensions. All right, so what this requires is us to remember from Physics 20 the component method, right? So in Physics 20, we were, we had like a, something traveling at, let's say, 45 degrees, 45 degrees, and then north of east, right? And then what we could do, remember, we could break this into its components, into its x component and into its y component. We're going to be using those same skills for Physics 30 now. Okay, so let's get to it. So for the most part for this one, there's just a bunch of examples. So I'll let you guys kind of look through these to kind of piece it together. And I think I will go through just the practice examples here. For the most part, though, you can kind of see. So calculate momentum before and then after, like we did before. But what it's going to be is we got to calculate for the x direction and then the y direction, right? So breaking it up into its triangles, like here and here, and then making a new triangle out of it in the end, right? So, all right, we'll go through some of that though. So if you guys want to, you can look at those examples. They're all good. Yeah, so the only other thing that we could do, right? You don't actually have to do this vector addition method. The typical method is to break it into its x's and its y components, right? And then add them all together, right? Some of the momentums in the x before, some of the momentums in the x after, and then make a new triangle out of it. If that doesn't make any sense, don't worry, I'll explain here in a minute. But the other way of doing it is this vector addition method. And with this one, what you would do is you'd use cosine law and sine law. And so that's just these ones. They really are equations where you just plug those numbers in, right? So it's not too bad. I'll show you how to do one of those as well. The reason we have to use these is because we're dealing with something that's not a right angle triangle, right? It could just be any triangle. So cosine law and sine law work for any triangle. But you'll notice these ones aren't on your formula sheet. So if you like this method better, you're going to have to memorize these equations. Or yeah. Okay, so again, you can look through these examples. It shows you how to use cosine law and sine law, but I'll show you that as well down here. All right, let's just get to the practice problems. All right, so number 1 here. So it says, I'm getting glitchy. 1 sec. All right, so it says a 4 kilogram object is traveling south at 2.8 meters per second when it collides with a 6 kilogram object traveling east at 3 meters per second. If the 2 objects collide and stick together, what is the final velocity of the masses? All right, so let's get our bearings and draw these things. So we have and what I'm going to do to make things easy, and it might be good for you guys to do too. You might appreciate this. Is here 1 sec. I got to get different colors going. All right, so what I'm going to do is I'm going to use different colors, right? So I am going to choose, let's say, blue for my x and red for my y. So anything going this way, I'm going to make blue, and anything going up and down, right, in the y, I'm going to make red. Okay, so that's going to be a bit of a rule here. It's going to just make it easier to see. Okay, so we have a ball, a 4 kilogram object traveling to the east, right? So let's write that down. So we've got 3, so velocity is going to be equal to 3 meters per second. And it's going to the east, I guess you could write down if you wanted to. And then it has a mass of 6 kilograms, 6.0 kilograms or 6 kilograms. Okay, so that's what's happening there. And then we also have, and I'm going to make this red because it's going down, right? We've also got a ball coming down, and it has a mass of 4 kilograms and a velocity of 2.8 meters per second. Okay, and maybe let's just call this, you know, M2 and V2, and then I should have made the blue one, should have been V1 and M1. Okay, so this is before, right? So this is kind of the same as the last lesson where we had like a before the collision happened. So we can do that too. So this will be before. Okay, and now we're going to have an after. Okay, so now after, we're going to have, I'll just make them both black. We're going to have both of these traveling off. Well, it'd be like in that direction, right? So you've had this ball and this ball stick together, and then they travel off on some angle like that, you would assume, right? Okay, so, and together, since they're stuck together now, we can assume that the mass afterwards, so you call that MA or M final or something like that, is just going to be the 4 kilograms plus 6 kilograms. And if you wanted to right now, you could probably do that math in your head. That'd be 10 kilograms. Okay, so we have that info so far. So now here's what we want to do. Is this one's pretty straightforward. We don't have like a lot of x's to add up, and we don't have a lot of y's to add up. There's only, they're already all in the x and all in the y. So what we're going to do here is just add up our vectors, right? And it still follows the same logic as before, right? So we can still say sum of the momentums before is equal to sum of the sum of the momentums before is equal to sum of the momentums after. So we put the prime on there. But this case, we're actually adding, because we're just, sum means add, right? We're just adding all these vectors. But remember, you can add vectors. You can add things in different directions. And the way we add vectors is by going tip to tail, right? So what that means is if I take, you know, my V, or my first momentum, oh, that was weird. My first momentum, this one over here, right? I'm just going to redraw that arrow, right? It's going to be that vector. And then we're going to have our red one up and down. So plus this vector, right? Tip to tail. This made a right angle triangle, right? So you can kind of see this arrow that I drew over here, the after. Well, that is going to be the resultant vector here. That's going to be made up of, sorry, all this switching back and forth. That's going to be made up of this one, right? The blue one and the red one added up to make the black one, the resultant vector there, the after. Okay, and then if you remember, we can make a little Cartesian plane. Well, my hand is really not steady right now. But anyway, you can make a little Cartesian plane there, and we can figure out the angle, right? And we can figure out the magnitude of the hypotenuse of that triangle. So just a little bit of trigonometry going on there, and that's really where this number is going to come from, right? Actually, sorry, not technically. We'll have to do a little bit of work to get to that number, but okay, so what we need to do first, though, is, just going back a little bit, let's take our two numbers here and here, right? The velocity and the mass, and let's figure out what the momentum of those things is. So let's figure out what P1 was. And the reason for that is because this vector, this diagram that I drew over here, these are momentums, right? You can't use velocities, this wouldn't be true, because you can't, it's not the sum of the velocities equal the sum of the velocities after. Sum of momentums equals sum of the momentums after. So we got to figure out the momentum, the blue one, first, and then the red one, right? And then those are going to be what goes on for my arrows there. Okay, so that's just multiplying them together, right? So 3 times 6. So this is going to be 18. And then what would my units be? Well, just actually put the units together, right? Kilograms times meters per second. So for momentum, it is just kilograms times meters per second, right? Okay, so that's what goes here. This is 18 kilograms times meters per second, okay? And we do the same thing with the red. Okay, so the momentum here, so P2, is going to be equal to 4 times 2.8. So that's going to be 11.2 kilograms times meters per second. Okay, so that's what this is. 11.2 kilograms times meters per second. If you see where I'm going with this, guys, I'm going kind of slow, but if you see where I'm going with this, like, you know, fast forward, finish the question, see if you can do it on your own. All right, so we've just got Pythagorean theorem here now, right, to figure out our resultant vector. So I'm going to go this one. So it's going to be a squared plus b squared is equal to c squared. So that's going to be 18. I'll forget the units for a second. 18 squared plus 11.2 squared is equal to, actually I'm going to call that r squared for my resultant vector. Okay, so then in the end, I'm hoping you guys can do Pythagorean theorem. We get an r value, or 21.2. And sorry, I'm going to change this again just to mess with you guys. Let's just call this the momentum r, right? Or the final, or whatever you wanted to, but sorry, this should have been a momentum, so p. Yeah, that was silly. Okay, r, or whatever you'd like to call it for the subscript, doesn't really matter. So then that was also kilograms times meters per second, right? So that's what this was. So 21.2 kilograms times meters per second. All right, so you think, okay, well, that's my answer. No, that's not my answer. It wanted velocity, right? So what we're going to have to do, we figured out what the momentum is. Well, that's a simple calculation now, right? Because we know that momentum is equal to mass times velocity, right? So if I want velocity, I just need to divide by my mass. So we'll say 21.2 kilograms times meters per second divided by, now which mass do I divide by, right? Which mass goes here? Well, this is the final. That's them together, right? That's the two of the things stuck together. So it's going to be 21.2 kilograms divided by 10 kilograms. Notice how my units cancel nicely, right? Kilograms cancel with kilograms. I'm now in units of meters per second. So that should just move the decimal place over 1, right? So in the end, we do end up with a velocity. So velocity is equal to 2.1 meters per second. Okay, so you might say, yay, we got the answer, that's it. Nope, not quite, right? That's why the answer has this stuff here. We need to do a little bit of Pythagorean theorem, right? We just need to find the angle right there. So the angle right there will be, well, you could really use any of them, but I'll use my more original numbers, my 18 and my 11.2. So this is my opposite, this is my adjacent, so that's tan. So I'm going to say tan theta, tan of the angle, is equal to, opposite is 11.2 over 18. Okay, so then angle is equal to tan negative 1 of 11.2 over 18. Okay, and then the angle is, all right, so I ended up with an answer of 31.8, or I'll just say 31.9 degrees. So then in the end, my answer would be 2.1 meters per second at 30, now I'm just going to call it 32. Should have been 32. There's 2 sig digs in the original answer, so 2 sig digs in my answer. So 32 degrees. And now we just got to say, like, you know, north of, like that whole north of west, the navigator method, right? So what am I here? This is going to be, so this is south of east. So south of east. And remember the way we do that, it's between the south and it's between the east, right? But it's coming like from the east. So that's why it's like of the east, if you remember that one. And you'll notice that my answer here, so this would be my final answer, right? That's not the same as the answer up here. Well, what's the difference? Well, it's, this one's east of south, right? My answer is south of east. Just for a second, what should this number and this number add up to? Well, it should add up to 90, right? Because they found this angle right there, right? I found this angle. They're both true, but like it's both, they'd both be correct, but just notice that if it was multiple choice or something like that, right? All right, so I probably spent way too long on that one question, but it was kind of a review as well. So just with all this trigonometry stuff again. So hopefully that made sense. And let's get into a harder one. All right, so a 100 kilogram mass traveling at 25 meters per second collides with an 80 kilogram mass traveling east at 20 meters per second. After an inelastic collision, the 100 kilogram mass moves away at 9.5 meters per second at 28 degrees south of west. What is the final velocity of the 80 kilogram mass? So this one's a little different, right? This first one, before they were coming this way and after they stuck together and moved away. So there was only really like, one defined there. Now we've got the two balls, or whatever they are, moving away in different directions, right? So we're just going to have a little bit more to keep track of here. So let's draw it out. Okay, so again, I'm going to call anything in the x direction blue and anything in the y direction red, okay? So, and I'm also kind of making anything on an angle black. But this kind of makes, just because it's not either, right? So you kind of need three colors if you're going to do it the way I'm doing it. So, all right, so just like what we did before, we're going to have a before and an after, right? So we'll have a before, okay? And we're going to have our, we'll call it, sometimes it's easy just call them ball A and ball B. Sometimes it gets a little bit confusing, but I'm going to call mine ball A. Well, actually, and in this case, they are both in the x direction, so I'm going to make them both blue. All right, just everything in the x is the same color, everything in the y is the same color. So I'm going to say ball A is going to have 20 meters per second and 80 kilograms. Kind of doing a little order. I did the second one first, but whatever. So ball A is going that way, and then ball B, right? Ball B is going that way, right? And it was at negative 25 meters per second and had a mass of 100 kilograms. Okay, so that was before. I'll dismiss that. Okay, and then after, actually right now, why don't we, like, let's just get in the habit too of figuring out what the momentum would be on each of these, right? Because we're going to need it. So let's just figure out, so now momentum of ball A in the, and we'll say in the x. It's all in the x anyway, but it's just going to be helpful for later to say like in the x direction, because we're going to add up everything in the x and everything in the y. So that'll be helpful. Okay, so we're going to say momentum of ball A in the x is equal to, well, it's mass equal to mass times velocity, so 80 times 20. So it's going to be 1,600 kilograms times meters per second. I'm going to put a box around that because we're going to need it for later. And then I'm going to do the same for ball B. So we'll say ball B, so momentum of B in the x is going to be, this is before, so negative 2,500 kilograms times meters per second. Okay, and that makes sense because it's going to the left, right? Okay, so now after what we get, and you want to make this as big as you can because we're going to use a lot of space here. These are like one-pager questions. So after the fact, these guys, so ball B, made in black, yeah, is going to be moving down at this direction, right? It said that it was at, so here, I'll just draw that line for now, and then we'll do the angle in a minute here. So if I draw that line down there right now, it said that it was moving away at 9.5 meters per second at, so I'm going to write down 9.5 meters per second. It's still 100 kilograms, right? But what we're more interested in than velocity there, because remember, we're not figuring out the sum of the velocities, we're figuring out the sum of the momentums. Right away, I'd like to just figure out what the momentum was. That's going to be more useful. So then I could say momentum, yeah, momentum of this guy, so of ball B after, right, a little tick, is going to be equal to, so the velocity times the mass, so 9.5 times 100, right? Okay, so that's going to be 950 kilograms per meters per second, right? Your times meters per second. Right, so that's going to be more useful, right? So now what we're going to do is that, like, whenever we get something on an angle like this, actually here, one sec. I'm going to maybe explain why we're doing this. So ball B is going to do that, right? So after the fact. Right, so think about what happened here. So if I look back at it before, these guys were traveling towards each other. And then ball B is now going off on this angle, right? Well, what happened there? Like, so if I got ball A, and I want to figure out, where ball A goes, well, there's really only two options. Like, I know for a fact it didn't go off in the same direction as B, right? That would violate Newton's third law, right? Like, you have them hitting and then going in the same direction. I think intuitively that wouldn't make sense to most people, right? But what you could have is that maybe it kind of bounced, right, and went back, went that way, or maybe it like sheared off the side of it and now it's going this way, right? We don't really know which of those things happened yet. But so what we're going to do is we're just going to choose one of them for now. And then we're going to, if the math will tell us if we're wrong. It'll tell us if we kind of had a mistake there or not, right? So now we got both our pictures for the after, right? So this is after. And what we're going to do, what we always do when things are written on angles like this, is I can't math angles. I can't figure it out when they're on angles. So what I want to do is I want to figure out, like, in the X and in the Y. We got to figure out the components of these guys. So I don't know the momentum of A after. But what we can do is we can piece it together. So if I figure out what that should have been blue. If I figure out what my momentum of A after in the X direction is, right? If I figure that one out, and I figure out what my momentum in the Y, so momentum of A after in the Y. So if I figure out those two pieces of the puzzle, then I can just use Pythagorean theorem to find that guy, right? So, and then use that guy to find velocity. There's a lot of steps here. All right, so that's the final goal. That's where we're after, right? So in order to do that, I also need to put this guy into its components, our B value. Oh, that should be blue. So I gotta figure out what this one is. So momentum of B after in the X, right? And then momentum, so just tip to tail, right? Those two should add up to the black one. So momentum, I didn't leave myself enough room there either. How can I do this? I'll just write it down here. Sorry. So momentum, I'll write it on the inside for now. Momentum of B after in the Y. Okay, so I'm going to need both those things, right? So and then I'll show you what to do with them once we figure them out. But this is going to be, straight trigonometry, right? We know this angle so far. We know this angle is 28 degrees because it was 28 degrees south of west, right? And this is south of the west. It's coming from the west. So this is 28 degrees. So 28 degrees, okay? So we got that one. So now, again, this is just using SOHCAHTOA. So if you're having trouble with SOHCAHTOA, please let me know. We got to figure it out now because we're going to do it a lot. So this side, we're going to be able to say, I'll write it down here because I'm running in the room here. Momentum. So momentum of B after in the Y is going to be equal to, so just doing, this is the opposite side, so it's going to be sine, right? So this will be the hypotenuse, so 950 times sine of the angle, so sine 28. So that is going to be 445.998. And I want to keep all my units as much as I can because the more I keep, the more accurate my answer will be in the end, right? And that will matter if it was a numerical response question, for example. Okay, so I've got that, and my units are still kilograms times meters per second. I'm also going to put a box around this because I'm going to need that for later. Okay, and now I got to find the other part there, so hopefully I got enough room here. I'm going to do it in blue. Okay, and maybe I'll just erase that so I can write it up here. So now we're going to have momentum of B after, God, pen's being weird. Momentum of B after in the X is going to be equal to 950 times, and this is the adjacent side, so it's going to be cos. So cos 28. So that's going to be equal to 838.8 kilograms times meters per second. I'm going to put a box around that because I need that as well. And then the other thing that I didn't do here, maybe you picked it up, which way are my arrows going? I need to be the one to attach a negative or positive to these, right? So this is going to have to be negative 838.8. And the last one there should have been negative 445.998. Okay. All right. So there's that. And then now that we've got, like, we're half done. So now that we have all those figured out, now what we got to do is we got to figure out our momentums, or it's pretty much the same equation that we had before. But this time it's going to be the sum of the momentums in the x direction is equal to the sum of the momentums after in the x direction. Right? So I'm just going to deal with the x, and then I'm going to deal with the y. So maybe I'll even start out the y on this side. So sum of the momentums in the y are going to be equal to the sum of the momentums after in the y. Right? And what this is going to help us figure out is this and this for each of these, right? I'm using the x one to find the x one, and I'm using the y one to find the y one. That's what we're after here. Okay, so sum of the momentums in the x. So let's start filling this out. So my first two things were in the x, right? These were both in the x, and that was before. So it goes on this side of the equation. So we're going to say 1600, or maybe I'll put the symbols first, so maybe you can like figure out what I'm doing here. Momentum of A in the x. Now let's do a blue. Momentums of A in the x is equal, or sorry, plus, there's a little vector there, plus momentum of B in the x is equal to, and then there's only, well actually there's going to be two different x's on the other side too, right? So there's going to be this one, and there's going to be this one, the one we're looking for. That's the whole point, that we can solve for this now. So we'll say it's going to be equal to the momentum of B after in the x plus, and there should be a vector, plus momentum of A after in the x. And this is what we're after, like I said, so that's good. And we know the other numbers. All right, so let's actually just fill those numbers in. So momentum of A, actually, you know what? Maybe let's just rearrange this and put that over the other side right off the bat. So we'll say momentum of A in the x plus momentum of B in the x minus momentum of B after in the x is equal to what we're looking for, momentum of A in the x. And now let's fill in our numbers and just make sure that we put the proper signs in there, right? So we've got 1600. I'm going to leave the units for a second because I'm getting lazy. 1600, and it's positive, and then plus negative, so I could say minus right now if I'd like to, minus 2500. And then this one was minus a negative, right? That's a negative, so that's going to be plus again. So minus a negative, so minus a negative would be plus 838.8, and that should be what my answer is. All right. Okay, so that's going to be equal to negative 61.20 kilograms times meters per second. And that's equal to PA after of x. All right, I need that. Okay, so that's one piece of my puzzle. I just found this one, right, for that triangle. So now let's find our y. It would be the exact same thing, just maybe even it's a little easier. Actually, it's going to be a lot easier because we don't have near as much stuff. So momentum in the y before, well, there was no momentums in the y to begin with, right? It was all in the x. So I can say before it was 0, and then after I'm going to have momentum of B after in the y, right? The one we know, the one we figured out right there, plus the vector, plus momentum of A after in the y, and that's the one we need. And what you'll notice is that if I rearrange this, I end up getting momentum of B after in the y, actually negative, sorry, because I brought it over there, is equal to momentum of A after in the y. And that makes sense, right? Because equal and opposite reactions. There's only this arrow going down and only this arrow going up. They must be exactly the same, just opposite directions, right? What else could it be? It would have to be. There's not like a random momentum in there somewhere. So that's kind of nice. So then I can just say momentum of A in the y is really just this number, right? But the positive version. So I can just say momentum of A in the y is just the number that we already had. It's 445.998 kilograms times meters per second. You guys will get tired of writing that down. Okay, and it's positive, right? Because it's the other direction. All right, so we have the info that we needed. What I'm going to do, just because I'm running out of the room, is I'm going to redraw that triangle down here. Okay, so we got our two sides of the puzzle here, right? So what we get is 445 straight up and down, and 61.2. So that one, here, maybe I'll write that there. So this was a momentum of in the y of, I'll even say A in the y, so we're keeping it consistent. Momentum of A in the y after is 445.998 kilograms times meters per second. Okay, and then we have it going this way, right? Because it's negative. So now we've got momentum of A after in the x is equal to negative 61.20 kilograms times meters per second. All right, so what I want you to notice, if we connect these lines here, so this one to this one, right? That should be a right angle triangle, by the way. I drew my triangle wrong, right? The one I originally had up, what's happening? The one I originally drew up here was the wrong way. It turns out it actually went that way, right? It actually kind of bounced back a bit. So my original assumption was wrong. But that's fine, right? We were wrong. The math told us that we were kind of wrong on that. So what we can do now is just Pythagorean theorem. So I'm in black, yeah. So we can say momentum of A after is equal to, and then Pythagorean theorem. So that's going to be 61.2 squared plus, and notice there's no negative there, right? Doesn't really matter, because if I had negative, I'm squaring it, so it doesn't really matter. It's gonna give me like a positive number anyway, or nothing on it, so either one. Plus 445.998 squared. It should have been squared. Okay, and that would be equal to, let's see here, I think I got it written down. Momentum of A is equal to 450.18 kilograms times meters per second again. All right, so that's good. So we figured out most of it. Now it wants the velocity though, right? Well, that's easy. The velocity, remember, momentum is equal to mass times velocity. So I just need to divide this by my mass, right? So momentum that we just figured out was, so velocity, sorry, we'll say. Actually, this would be speed, no, this would be velocity, yeah. Is going to be equal to 450.18 divided by, and this was the 80 kilogram mass, right? So it would be equal to 5.6 meters per second. All right, so we're almost there. This is a long question. So that's what we just figured out the velocity for this guy was. Now we just need to figure out the angle. So I'll use tan. I could use, so he's writing P. I'll use tan because it doesn't really matter, but theta is equal to, the opposite was 61.20 over 445.998. So the angle is equal to tan negative 1 of, I gotta write it all again, 20,445.998. Okay, so the angle is 7.8. Yeah, 7.8 degrees. All right, so is that the same as the one they had? I bet you it might not be. It is. All right, they did the same as me. All right, so 5.63, 5.6. Yep. All right, so then it's going to be 5.6. So in the end, our velocity is going to be 5.6 meters per second at 7.8 degrees. And now just make sure we get this right, right? Because it's coming from here. This is the west and this is the north, so it's west of north. Phew, that took a long time. All right, that's this unit. The rest of the units aren't so bad like this. All right, how many more do we have? All right, we got one more. This one's kind of nice though because they drew the picture for us. So it says the Canada Day rocket, mass 25 kilograms, is moving at a speed of 50 meters per second to the right. So this one. So you can right there, 25. Actually, I'll do it blue again. .25 kilograms, moving at a speed of 50 meters to the right. 50 meters per second to the right. The rocket suddenly breaks into two pieces. So you've got an 11 kilogram one and a 14 kilogram one. So we'll say, you know, this one we'll say is the 11 kilogram one, and this will be the 14 kilogram one. And they fly away from each other as shown in the diagram. If the velocity of the first mass is 77 meters per second, so 77 meters per second, 77.8, sorry. 0.8 meters per second at 30 degrees, so they gave that to us, 30 degrees. What is the velocity of the other piece? So this one. So we got to figure out what the velocity of this guy was. All right. So we need to split this guy up into its components, right? So let's split the bottom one like that. And then you could draw these triangles on either side, right? I could draw, you know, this line from there to there, right? That would work. That'd be fine. But you could also draw it from there to there, right? It doesn't matter which side of the triangle you do it on. I'll draw it down there just to keep it. Or, yeah, I guess that shouldn't have been blue. It should have been down here, I guess, if I was doing that. But yeah, it really doesn't matter which one you do. So let's do it that way. So that way, and then I'm gonna draw this one like that, and then my reds will be that side and that side. All right, so looks something like that. I only did that just to keep like the blues away from each other because they just get confusing. So what we're gonna do is find this angle in the end, and then go 90 minus that to get this. Okay. All right. So what we need to do here first, figure out like the things that you're able to figure out, right? So this blue side right here, right? We can figure this one out. So we'll say this was, and they use 1 and 2, so we'll stick with 1 and 2. Momentum. Make that blue. So momentum of 1 in the x direction, and that was after, right? Is going to be equal to, well, I guess we got to figure out what the momentum is. So let's figure out the momentum of 1 after, and that's just going to be 11 times 77.8. So 855.8 kilograms times meters per second. Okay, so that's what, that should have been black, by the way. Okay, so I know that one. So now momentum in the x is going to be 855.8 times, and then this is the adjacent side, so it's going to be cos 30 degrees, right? So momentum of 1 after in the x it will be, momentum after in the x will be 741.14. That's positive. Because it's going to the right. Kilograms times meters per second. All right, like I said before, anything you're going to need for later, put a box around. Okay, so I got that one figured out. Now let's figure out my red one, or my y. So it's going to be very similar. It's going to be momentum of 1 after in the y will be 855.8 times, and this is the opposite side, so it's going to be sine 30 degrees. So momentum of 1 after in the y will be, where do I have this written down? Oh yeah, right there. 427.9 kilograms times meters per second. Okay, so we got that one, and that's pretty much it. We found all the things we need, and now we can do the same as we did in the last one. We're going to have momentums in the x before, momentums in the y, or yeah, you know what I mean, hopefully. So, okay, so let's go. Sum of the momentums in the x before is equal to the sum of the momentums in the x after. And then over here, we're going to have sum of the momentums in the y before are going to be equal to the sum of the momentums in the y after. All right, so let's do x's first. So draw. Okay, so before, oh, we forgot one thing. Before, so momentum in the x is equal to, so that's just going to be those two multiplied together, right? So 25 times 50, 1,250, that shouldn't be a decimal there. Kilograms times meters per second. Okay, so then before, that was it. That was the only thing we had before in the x, right? It was one piece. So we had, so momentum in the x, so that was the only thing, is equal to, and then momentum's in the x after, well, we got 2 because we're missing this one, right? This was the momentum in the x, so momentum of 2 in the x after. And yeah, so we're missing that one. So we want to figure out what that one was. So that's going to be momentum 2 after in the x plus momentum of 1, or yeah, 1 after in the x. And that's it, right? It's just this one plus this one would equal that one. Okay, so let's fill in what we know. So this is to the right. So we've got 1,250 kilograms times meters per second. It's positive, is equal to, and then this is the one we don't know, right? So P2 of x plus, and then we've got plus, I should have just subtracted it from the beginning. Well, 741.14 kilograms times meters per second. Okay, so I'm just going to solve for, I think you guys would know to subtract that, right? So I'm going to say P2 after of x is equal to, I'm just going to actually subtract them now. So we end up with 508.86 kilograms times meters per second. Okay, I'm going to need that for later, so I'm going to put a box around it. All right, and then our y's are going to be pretty straightforward because they should be the same number, right? I didn't really draw it that well, but they should have been, right? Because if you think about it here, I've got this y going up and I've got this y going down. They have to be the same, right? They should have been the same length arrow when I actually did this, but you know, I didn't. So it's going to be this number just in the other direction. So I could do it all, like, you know, write it all out if I wanted to. But maybe you're clever enough just to kind of realize it when you drew it. You could put that number in right away, and maybe save you some time. So I'm going to do it that way. I'm just going to put in negative 427 0.9, right? Just this number, but negative kilograms times meters per second. Right? So I didn't even have to do any of that, right? I knew that that has to be the case. All right, so we've got all of our pieces of the puzzle now, right? I've got this side. That's 14 kilograms, kind of deceiving. So I've got both sides, right? So maybe I'll just draw like another triangle down below to make it a little bit cleaner. Okay, so we had this arrow, which is what I just said, negative 4, 27, gotta get a bad memory, 0.9, negative, stay. And the blue one was this number, right? And it was positive to the right. So 508.86. And now, oh, not insert, draw. Pythagorean theorem, right? We're going to use that to find that. And like I said, the angle that we're finding here will be a little different than the one they want, so we got to use that at the end. So anyway, okay, so we're going to say, oh, God. So this was momentum of, what number was it? 2 after. Okay, so we'll say momentum of 2 after, and I'll just do Pythagorean theorem here, squared is equal to 427.9 squared plus 508.86 squared. So in the end, I can just say P squared is, or not squared, I'll just say P2 after is equal to 664.86 kilograms times meters per second. All right, so then again, I think it wanted the velocity, right? What's the velocity of the other piece? Yeah. So velocity is equal to momentum divided by mass. So the velocity here is going to be 664.86 kilograms times meters per second divided by, and then our mass was, what was our mass here? Our mass was 14 kilograms. So velocity is 47.5. 47.5 meters per second. All right, we were so close. All right, so then lastly, we got to figure out what this angle is, right? So I'll say the angle is equal to tan negative 1 of opposite over adjacent, so that's going to be 508.86 divided by 427.9. I forgot to push record somewhere. Hopefully you guys, I think it was around here. Hopefully you guys can kind of see and just see what I did there. Yeah. Okay, so, oh, sorry, I said south of east. That is wrong. That should be east of south. East of south, right? The way that I found this angle, which is really similar to what the question is here, or what their answer is. It said 40.1 below the horizontal, right? Well, that would be, we just found this, right? So if I went, so if I said this was 50, all right, so 90 minus 50 would give us 40. And technically, yep, our answer, since this was only 2 sig digs in the question right there, our answer should have only had 2 sig digs as well, technically. So yeah, they said 40.1, that technically should have been 40. All right, so that is it. Hopefully that made sense. I'm not going to go through doing the, so that was the component method. The vector addition method, I'm going to leave. We don't need to do that one. Tell you the truth, it'd be a lot quicker though if you are able to figure that one out. Maybe I'll make a video on it. Maybe I'll just show you in class. So, all right, so that'll be it. See you guys in class.